Hey guys, let's look at this 2013 free response question number 1. So we're given this function g, which is the rate at which unprocessed gravel is arriving to this plant. In part A, we want to find the derivative of that function at a particular value of time, and then interpret that answer in the context of the problem. So g, which is measured in tons per hour, so g prime of 5 will be equal to negative 24.588. And if g was in tons per hour, our units here will be tons per hour squared. Now, I also think it would be best if you take this function g and you put it into one of the y slots in your calculator. That way when you go to take the derivative, you can just say take the derivative of y1 as opposed to having to type that out over and over again. So now what is this? G is the rate at which unprocessed gravel is arriving. So the derivative of that will tell us whether that is increasing or decreasing, and also by how much. So the rate, which is G, unprocessed, I can't even spell it, it's right there. So the rate at which unprocessed gravel is arriving at the plant is decreasing by 24.588 tons per hour squared when t is equal to 5. So since g is the rate at which that gravel is arriving, if we want to find out the total amount that has arrived at the plant, the total amount will be the accumulation of that rate, which we can find by using the definite integral. So the hours of operation of this plant, our lower limit is 0, our upper limit is 8. And again, since we've already plugged it into like that y1, we can now just call up y1 as opposed to having to type out that lengthy function. Okay, so that many tons arrive at the plant during those 8 hours. Okay, part C seems a little bit trickier than I think it has to be. So if we want to know whether the amount of unprocessed gravel at the plant is increasing or decreasing, then what we want to do is we want to compare the rate at which we're processing gravel to the rate at which it's arriving. So if we read that problem, we know that we can process gravel at a rate of 100 tons per hour. And gravel arrives according to that function g. So here's how much arrives. $98.141 tons per hour. So we process gravel at a rate of 100 tons per hour, and it's arriving at a rate of 98.141 tons per hour. Now, since we're processing gravel faster than the rate at which it's arriving, the amount of unprocessed gravel is decreasing. So the amount of unprocessed gravel at the plant when t equals 5 is decreasing, since that rate at which it's arriving is less than the rate at which we're processing it. Right. I forget what part D is asking. Okay, so what is the maximum amount of unprocessed gravel at the plant during those hours? All right, we haven't really talked about the amount of gravel that was there yet. I guess we talked about the total that kind of came within the 8 hours, but we didn't talk about how much was actually there. So if we want to think about a function for the amount of unprocessed gravel, well, at the beginning of the day, there was that 500 tons of unprocessed gravel. So we have that initial value of 500. It arrives according to that function g. So if we wanted to know the total amount, we would have to take the definite integral from 0 to t of that function g. I'm going to change my variable here, my dummy variable, just so don't have my upper limit and my function to be defined as the same variable. But we're also processing gravel, so we have to take into account the amount of gravel that we're processing, 100 tons per hour. So for any value of time, we have 500 that was initially there, plus how much had arrives from 0 to whatever value of time we want, minus the 100 tons per hour that we've processed. So now, when will this be a maximum? Since this is our function a, our derivative, a prime, will be equal to, well, the derivative of 500 is 0. The derivative of the antiderivative is the original function. I can change this back to t now. Sorry, fundamental theorem of calculus. So g of t minus the derivative of 100t is 100. And we want to know, when will this be equal to 0? So when will g of t equal 100? Now, since we've already kind of put that function g into our calculator, we can graph that. We can graph the line 100, find the intersection point. T is equal to 4.923. Okay. So now this is one of those things where it says when is what is the maximum amount. So we also have to make sure that we take into account our endpoints. So maybe that we process gravel so quickly that the most unprocessed gravel we have is at the very beginning of the day, and then we're such good workers that that amount decreases throughout the course of the day. So here are some values of time that we need to test. We need to test 0. We always want to test our endpoints, and we know that there's 500 tons of unprocessed gravel at that time. We want to test this value 4.923, and to do that, I'm going to plug that into my function here. So the definite integral from 0 to 4.923 of g minus 100 times 4.923, and then add in that 500, we get 635.376, and we also need to test our endpoint, 8. Now, we already know 0 to 8 from part B, so I can just take this number minus 800, because I'm plugging in 8 for t, and then add that 500. So again, how I did that, I did a of 8 was equal to 500 plus, we already knew that value. We already know this value from 0 to 8 is 825.551, and then minus 100 times 8, or 800. So we get 525.551. Now comparing these, 500, 635, and 525, we can see that the amount or the maximum amount of unprocessed gravel is that 635.376 tons. It's kind of some ominous music to be ending this on. All right, this is, I think, one of the ones where it's like the calculus and the math kind of get lost in what you're doing. So take it step by step and try and find out the words that make sense. And try and do as many of the little pieces as you can. All right, this is the first one. I guess there'll be 5 more to follow, but best of luck.